saw it. It was a fabulous show if you ever get a chance to see him. This was back when she was a little younger. She was on my baseball team. She didn't want to play with the boys. She wanted to play, she didn't want to play with the girls at that time. She wanted to play with the boys. And so she did. And I remember, I'll never forget the day I said, I got this big bag of catcher's equipment, and I'm standing there in front of the team, and I said, okay, who wants to be the catcher? Here's the equipment that you have to wear if you're going to be the catcher. And she went, I do. And there she is, and she just loved running into people and having people run into her at home plate. And she went on to become a first-team All-State softball player, and had college scholarship offers actually, but she didn't want to be an athlete. She wanted to be a student, so she went to Oregon and did that. It's funny. She called me one day. She'd been down at Eugene for maybe 3 weeks, and she says, Dad, I've been hanging out there at the softball field, and I think I could make the team. I said, John, go for it. Just go for it. She calls me back a couple days later, and I said, well, did you make the Duck softball team? She says, I didn't have my glove down here, so I didn't go. And so she became a CPA instead. Just as a word, though, the girls' softball team at the University of Oregon travels 25,000 miles a year by bus and plane. And she says, you know what, that's a lot of time sitting. I'd rather be studying and learning something. All right, we're going to talk about the digestive system. It's probably the one I'm the best at because I did general surgery, and we obviously operated on the guts a lot. Here we go. There she is when she was first team All-State catcher back in 2004. Man, time goes by. I don't know when that first picture was. It was probably in 90. Maybe. Oh, this is me and my daughter at her wedding, and something just very funky happened.
There it goes. There it is.
Okay.
No.
This is us dancing with Daddy. Anyway, okay, so let's talk about the digestive system. Enough of my crap. What does the digestive system do for you? Well, it does these things. First of all, it acquires all of your nutrients. Sometimes we get fed through an IV, and sometimes we get fed other ways, I guess. But basically, we acquire all of our food and all the nutrients and the stuff that's going to keep us alive through our mouth. Anabolism is, it brings these nutrients in that we can put together and synthesize together to make complex compounds out of. It also brings in things that we can break down, like sugar. We can break it down and form energy and make ATP and all of that good stuff. A couple things about these catabolic reactions. They're the breakdown reactions, and every time we do that, we need oxygen. Oxygen is one of the main ingredients anytime we're doing catabolism and trying to make ATP, make energy. We also, but even before, but in addition to oxygen, we also have to have these organic molecules that you eat every day, carbohydrates, fats, and proteins. In fact, if you look at any box of anything, it tells you how much carbohydrate, how much fat, how much protein there is on it. We also need some vitamins. We'll talk about them as well. Okay. So, one thing I think it's important that you understand is that the digestive system, or the GI system, gastrointestinal system, goes from your mouth to your anus. Okay, it's one long tube. it's a muscular tube. It's lined with muscle that works the food along and pushes it along and so forth. There's a whole bunch of stuff that comes in to mix with the food as it goes from your mouth to your butt. And as it does that, it goes through your pharynx and your esophagus and your stomach, 3 parts of your small intestine, your large intestine, and then it goes out through your anus. I think it's really important that you understand that anything that's in your GI tract is not in your body. Does that make sense? I mean, even though it's sitting there in your stomach, for example, it's not inside of you. It's not inside of you until it's broken down and absorbed through the walls of the bowel, and then it really becomes part of you. A lot of stuff that we eat goes in here and comes out there, and we never get anything from it. The number one thing is what's called cellulose, which is basically fiber. And you probably remember back from 112 about how plant cells they didn't have just a cell membrane around them, they had a cell wall, and that wall was usually pretty thick, and that wall was made up of cellulose. Well, we cannot absorb cellulose. So every bite of cellulose that you eat goes out the other end completely unprocessed.
We're just a giant meat donut.
Well, sort of. Some animals can eat cellulose. Cows can eat cellulose, and that's because they have several stomachs, and they eat the food, they digest it, they store it in one of their stomachs, then bring it back out, and in the process they mix it with a whole bunch of bacteria. They have a whole bunch of bacteria that live in their stomach and in their intestine, and it's those bacteria that break down the cellulose so that they can actually get some good out of it. Obviously, without that, they wouldn't be able to make it on hay. Okay, so here's the components of it. It runs through real quick here. The mouth, the oral cavity involves your teeth and your tongue, and it's where the processing of food actually begins. The first part is mechanical processing, which really means we chew it up, we break it down, we mix it with saliva and with water, and mix it with our salivary secretions. Also, our salivary secretions from our salivary glands or our spit glands have enzymes in them that start to digest this stuff. Comes on down through the pharynx back here. We talked about the nasopharynx and the oropharynx and the laryngopharynx last chapter, right? And then assuming it doesn't go into the trachea, which we don't want it to, it goes right down the esophagus, enters into this storage thing here called the stomach. From the stomach, it goes on into the small intestine here called the first part of the small intestine is called the duodenum. And there, secretions from the liver. This is the liver. The main secretion is called bile. Bile is secreted into the bile duct and then sometimes stored, usually stored in the gallbladder, as opposed to the other bladder, or urinary bladder. It stores there, and then every so often the gallbladder squeezes down and pushes the bile in to mix with the food here, and then it goes on downstream. You also have the pancreas here. The pancreas is a big organ that's really deep. It's kind of a mysterious organ, I have to tell you. It secretes a lot of fluid, a lot of enzymes, a lot of alkaline material. Basically, remember your stomach makes acid, a lot of acid to break down your food, and then the pancreas secretes a bunch of basic or alkaline juice in order to neutralize that, so that by the time the fluid gets about right there, right in the duodenum, it's neutral, and it goes the rest of the way through us in a neutral state. From the duodenum, it loops around here and back, enters into the next portion of the small bowel, which is called the jejunum. The third portion is called the ileum. This is called the terminal ileum here, where the ileum empties into the cecum. Cecum is this first part of the colon. There's the appendix hanging off of it. We'll talk about it a little bit. Then the colon there's an ascending colon, also called the right colon, where it's going up. It has a transverse colon, which goes across. It has a descending colon, which goes down. It has an S-shaped piece of colon over here called the sigmoid colon. And then it has a straight shot out here called the rectum. Now, rectum means, what?
Is it straight?
Straight, yes, straight. So the rectus muscles are straight muscles that pull our eye in one direction or another. This is our rectus abdominis muscle that gives us a six-pack here on our tummy. That's where the word rectus comes from, and indeed that's where rectum comes from. It's the last straight shot coming out. More components here. Salivary glands make a bunch of spit, has enzymes in it. The pharynx is its whole idea is to kind of wad the food up into bite-sized boluses, push it on down. Esophagus is merely a transit tool. Food does not stop at all. It goes about this fast. You swallow, and it goes, boom, empties into the stomach. So food doesn't really spend any time in the esophagus. The stomach, food usually stays about 2 hours in your stomach. It's where it mixes with all kinds of enzymes and lots of acid and lots of munching up and all these contractions of the wall of the stomach to continue to soften it and moisten it and mix it good, and then it starts being passed on down the intestine. There's a little valve coming out of the stomach called the pyloric valve that contracts and holds the food in the stomach for about 2 hours to allow it to do all that digesting. What are the functions of this digestive system? Ingestion is when you actually put stuff in your mouth. Then it begins this mechanical processing system of crushing it with your teeth, ripping it to pieces with your teeth, and making it softer so it doesn't hurt so much when you swallow a big bite. And like your mother always said, chew up your food, right? You need to do that for it to work, and so it doesn't, first of all, so it doesn't hurt your esophagus when it goes down. So that's the first part, is the mechanical processing, just getting it wet and soft. Then the second part is digestion. Digestion is the chemical breakdown of food into small fragments. In other words, we can't absorb across our intestinal mucosa a hamburger. Now, if we take that hamburger and get it all wet and get it all broken down into glucose and into proteins and amino acids and into fat droplets, then we can absorb it. But we can't absorb it until it's been through this digestion thing. Almost all of the absorption of our food occurs in the small intestine. Nothing really gets absorbed in the mouth. Nothing really gets absorbed in the stomach. It's not until it gets into the small intestine that things get absorbed across into our bloodstream. And then it goes into the colon. The colon really doesn't do much for us at all, but you're all glad you have one, I'm sure. Secretion is another part of digestion. And by that secretion, I mean that the body secretes all kinds of stuff that goes into this long tube. And so a lot of it is water, acids, enzymes, buffers, salts. Most of it is actually secreted by the epithelium of the digestive tract. The rest of it is secreted by these glandular organs like the pancreas and like the liver. Then we have to absorb it. Absorption is just what it says it is. It's actually absorbing these fragments, electrolytes, vitamins, substrates, water, absorbing it across the mucosa and letting it get into our body. A lot of it goes through the cells that line our digestive tract, and a lot of it even just enters into the interstitial fluid of the digestive tract, that fluid that's around the cells. And then finally, the last phase of digestion is excretion. In other words, getting rid of stuff we don't want. Now, some of that is stool, but some of that is just extra water. Sometimes that's extra salt, sometimes that's poisons. Actually, one of the ways we have of breaking down some poisons is to process them through our liver, and then the liver secretes the breakdown products, and then it all goes out through our rectum and is excreted. The lining of the digestive tract has to be pretty magic. It has to be strong enough to resist a pH of 1. The pH in your stomach is 1. That's pretty acidy. You know, you remember that old acid to base? You know, 1 is acid and 13 or 14 is the ultimate base. That the stomach lining has to be very tough to do that. It has to not let those acids eat up our own stomach. Makes sense? Parts of our GI tract have to be very strong. For example, our mouth and our esophagus have to be tough enough that we can swallow things like potato chips and chicken bones and scratchy food, okay? And it won't cut our inside of our digestive tract on the way down. So the way we do that basically is because the mucosa of those parts of the tract are made of what kind of epithelium? Stratified squamous, that's right. And that's true down to the lower end of your esophagus. And at the lower end of your esophagus, then, the rest of your entire bowel is lined with simple columnar. Okay? Now, it's all simple columnar. It's all going to look a lot different. They're in different stages of the bowel. But just know it's all simple columnar from there down to about the last, 2-3 centimeters of the anus, just before it comes out. And then once again it goes back to that stratified squamous. Because, sometimes you've probably passed some sort of scratchy stuff out the bottom, and you just kind of needs to be a little tougher down there. Enough said. Your bowel has to be able to resist lots of bacteria. We have a lot of bacteria in our bowel. Although once it gets in the stomach, the acid of the stomach generally kills all the bacteria. So it's pretty much sterile. And then it works its way down through your small intestine. And the small intestine is usually pretty much sterile. And then when it gets into the colon, the bacteria start growing back. And by the time we pass a stool, our stools usually have like 10 to the 6th bacteria per microliter. I mean, there's lots of bacteria in it. Not near what's in your mouth. Here's a lesson for clinical medicine. If I punch you in the mouth, boom, and you kind of go like that, and I catch one of your teeth on my hand, that little cut is now completely infected with the bacteria from your mouth.
You are welcome, sir.
Yeah, that's why you don't ever want to punch anybody in the face or in the mouth. For your own protection, because when you go into the doctor or into the hospital, they're not going to sew it up, because it's guaranteed to get infected. It's got so many bacteria in it from contact with your mouth and your saliva that it'll never heal. So you always just pack it open. You might kind of change dressings and clean it up for a few days, then have the patient come back and maybe put a few stitches in real loosely to kind of help draw it back together. But remember that the bacterial content of your mouth is more than anywhere else in your body. I won't say it. So anyway, let's talk about the kind of oversight of all of this. The digestive organs, most of them live here in your abdomen. And as they live in your abdomen, they live in the peritoneal cavity. You remember that? You remember that picture from 231 of the big balloon And here's a guy with his fist. He puts his fist into the balloon. You remember that? And we said that the way to, this is so this line is the kind of lines it like that, and then we end up calling this. What do we call that layer of the peritoneum? Visceral. Very good. The visceral peritoneum. And what do we call this layer out here? Parietal peritoneum. That's right. All right. So remember that almost all of your abdominal organs grow in from the back of your belly, and most of them are covered by this serous membrane, which is peritoneum. Okay, so it's really visceral peritoneum, which makes up the outside layer of all of your guts that are in your abdomen. The inner lining of the wall, when you open the abdomen and look at your kitty cats inside on the inside wall of their abdomen, that's all the parietal peritoneum, right? Now, but they're really connected, right? Just like this is connected up here, right? They're all the same layer. It's just that we call this layer that's on the bowel visceral, and the one that's on the outside parietal. That was not good. Did we lose power? No. Okay. Peritoneal fluid is when you open an abdomen, we would usually find 5 cc's of fluid in the abdomen. Just enough to keep everything slickery up. Same as in the pleural spaces, which we talked about with the lungs. Just enough to supply a little lubrication. And you can lay there at night and hear your bowels moving and rolling around in there. Well, it would hurt a lot if they were scraping over the wall every time they moved a little bit. So this peritoneal fluid separates the parietal and visceral surfaces, allows sliding without friction or irritation. Let's talk about mesenteries. Mesenteries are these double layers of peritoneum that come up from the back. So let's just take and draw a little picture here of a loop of bowel. And so if this is a piece of bowel, say this is your small intestine, just along about in the middle of your bowel. And that's the wall, and so there's muscle in here, and there's mucosa on the inside, and so forth. And that's where the food is, okay, on the inside. And then on the outside of that is a layer that we were just talking about called the visceral peritoneum, okay? And that layer of visceral peritoneum, also called the serosa, we'll come back to this, but it lies on the outside there. And then this comes back down here in the back of you, and then it becomes the parietal peritoneum, right? And then up through that little connection here is an artery that's carrying blood up to the intestine, veins that are bringing blood back, and some nerves and lymphatics and stuff in there as well. So this thing right here that you can feel, that is what the bowel is suspended by when you grab a piece of bowel and hold it up. That's called the mesentery, okay? This is the mesentery right here. And this is really best seen in your cats, you know, so when we do the digestion dissection, you'll want to pay special attention to this. This is areolar tissue. There's just a lot of loose tissue in there along with the blood vessels and so forth. The other thing the mesentery does is it sort of stabilizes the bowel. Now you can pick up a piece of bowel and move it, you know, but only a certain amount. You can't pull it out and turn it around and drop it back in. It is restricted in its movement. And that's a nice thing because that prevents the intestines from becoming entangled. If they were just loose and laying in there like a bunch of spaghetti, it would tie itself in knots all the time. But the mesentery kind of holds it straight enough so that it doesn't get entangled like that. Other thing I want to explain to you, and this is really better to explain in the lab, is that if you could take the abdomen, and let's just say this is a cross-section of the entire abdomen, okay? So here's the abdominal wall on the outside, and this is the peritoneum right here. So this is abdominal wall muscles and stuff like that. And then here's the peritoneum that's lining the whole abdominal cavity. Well, when we were little bitty babies, what happened was the bowel started to form out here in the middle, and we had a little mesentery that came down from the ventral surface, the tummy surface, and we also had a little mesentery that came up from the back called the dorsal mesentery, okay? So we used to have both of them, supporting it from both sides. But as we went on and matured more and so forth, then most of this ventral side went away. So it kind of then began to look like this.
That's a dorsal, isn't it?
But
That was the dorsal.
this was dorsal. Okay. Then this one went away. All right, so this one went away and this one stuck around, is that right? So this is the back dorsal surface. Y'all can go for that? Okay. Well, the fact is there's two little pieces of that ventral mesentery that have persisted, okay? And so when you look at your kitty cats and when you're doing that dissection, be sure that you understand the two parts of the ventral mesentery that are still there. And I can guarantee you, you will be asked this. The two parts that are left are called the lesser omentum. The lesser omentum comes up to the stomach, and the falciform ligament, which comes down from the front up here. And you'll be able to see that as well on your cats. Now those are simply the remnants of what used to be a complete ventral mesentery, but it's all gone away except for those two things. Oh, here's the picture that I was trying to draw that was so much nicer. There it is, right there. I'll let y'all study that later. The lesser omentum, it comes into the lesser curvature of the stomach, provides access for the route of the blood vessels and the other structures. And really the only way for me to explain it to you is just to show it to you in lab. So when we start doing that, be sure and grab me and I'll be happy to show you both the lesser omentum and the falciform ligament. Falciform ligament basically runs from the belly button up here through the liver and kind of attaches on back to the back side. What do you think used to, think about this, what used to run through that falciform ligament?
The umbilical cord.
Oh, the umbilical cord. Well, not really the umbilical cord, but it attached here.
Yeah.
But then the vessels that came from the umbilical cord would go up this way, and we call that the ductus venosus, right. Okay. So you remember some of that, that's good. The dorsal mesentery is the big one, and it also has this big pouch that hangs off the greater curvature of the stomach called the greater omentum. It extends down the front of your abdomen here. We used to call it the policeman of the abdomen, and it's because it was just this fatty apron thing that draped across the bowels. But when you got appendicitis, and appendicitis occurs down here, your whole omentum would work its way down and try to wall off and surround the appendix so that if the appendix did rupture, it could kind of wall it off and keep the infection localized. If you had diverticulitis in your colon, then the omentum would work its way down into the left lower quadrant. You kind of try to wall that off. Same thing if it was your gallbladder up in your right upper quadrant and it was really sick, the omentum would move up there and try to move around it. Once again, it's just a bunch of fat. It's where I think most of my weight is in my omentum. Because my abdominal wall is just rock hard and so tough. I know that's where this fat must be and I just can't get at it. Anyway. The mesentery proper is this main piece of this stuff back here that really suspends the entire small intestine, allows us some independent movement, but not that much. And I think I'll just leave it like that because you can see it so easily in lab. But the mesentery proper is the main piece of double peritoneum that's going up to the loops of bowel. The colon has a mesocolon too. You'd like to call it a mesentery, but we call it the mesocolon because it's going to the colon. And it's not quite the same because it doesn't get up there on a stalk like this does. The colon usually would be laying like this. It would be laying right here, and the peritoneum would kind of come over it like that, and maybe cover parts of the wall, but not all of it. So the mesocolon, you'll see it. It's a nice little structure. Here is a picture that illustrates a lot of this stuff we were just talking about. Let's start with the mesentery proper, which is this band of the double peritoneum like we talked about that goes to most of the entire small intestine. The colon, which lays against the back wall pretty much, has, this is the mesocolon, this is the transverse mesocolon, this is the left mesocolon, and then there's a sigmoid mesocolon down there. So they all have this, that's the way the blood vessels get into the bowel to keep it working properly. The stomach up here has the lesser omentum. This is that one that used to be coming from the ventral side, which goes to the lesser curvature of the stomach. So that's one of the two remnants of the old ventral mesentery, the lesser omentum. The greater omentum, which is along the greater curvature of the stomach, it has this big apron that hangs off of it. And indeed, they've cut it off here in this picture, but it can hang way down like that, and it usually does. Yes?
So is it the leftover from the dorsal ventricle, the greater omentum?
The greater omentum
Yeah, is the like leftover from dorsal?
from the dorsal mesentery.
Yeah. When you were a baby, like this picture, you said one is gone and one is left.
Yeah, it's sort of that, but it's not really a mesentery at all. There's really not blood vessels going into the stomach from out here. So I wouldn't really